August 15th, 1977. Elvis Presley is still alive. The first Star Wars film is breaking box office records. And somewhere in the vast darkness between the stars, something is calling out. At exactly 10:16 p.m. Eastern Time, a radio telescope in Ohio picks up a signal so powerful, so precisely tuned, that it sends a chill through the spine of the scientist who discovers it. He circles the reading on his computer printout. He writes one word beside it in red ink: wow. That single word would echo through the decades. Because in the nearly 50 years since, despite hundreds of hours of searching with the world's most sensitive instruments, that signal has never repeated. It remains the strongest candidate for a message from another civilization ever detected. Or was it something else entirely? A cosmic coincidence? A fleeting whisper from a dying star? Or the last fragment of a conversation that began 1,800 years ago? Tonight, we journey into one of astronomy's greatest mysteries. The signal that changed everything, and the silence that followed. This is the story of the WOW signal. The Ohio countryside, 1977. While most Americans were watching their televisions, a strange metal structure was listening to the cosmos. The Big Ear Radio Observatory. 3 football fields of aluminum and steel, shaped like a vast parabolic trough. It was the brainchild of Dr. John Krause, a radio astronomy pioneer who dreamed of hearing the universe's whispers. The telescope was unlike anything else on Earth, flat, massive, and impossibly sensitive. For 14 years, the Big Ear had been scanning the skies, searching for signals from other civilizations. It was part of a program called SETI, the Search for Extraterrestrial Intelligence. And in 1973, it became the longest-running SETI project in history, earning a place in the Guinness Book of World Records. But by 1977, the telescope's glory days were fading. Funding was drying up. The equipment was aging. And the volunteers who kept it running were working with outdated computers and endless reams of paper printouts. One of those volunteers was Jerry Ehman. A professor at Ohio State University, Ehman wasn't a professional astronomer. He was a data analyst who had volunteered to help process the mountain of information pouring out of the Big Ear. Night after night, he sat at his kitchen table, poring over endless columns of numbers, searching for patterns in the cosmic static. It was tedious work. Most nights, the printouts showed nothing but background noise, the random hiss of hydrogen atoms, the crackle of distant quasars, the occasional burst of interference from aircraft or satellites. But Ehman kept looking. Because somewhere in that noise there might be something else. A signal that didn't belong. A voice from the void. On August 18, 1977, 3 days after the signal arrived, Ehman was reviewing printouts from the night of August 15th. The data scrolled past in endless columns. 6, E, Q, U, J, 5. He stopped. His eyes traced the sequence again. The signal had risen from nothing, peaked at an intensity 30 times stronger than background noise, then faded back into silence. It had lasted exactly 72 seconds. And then it was gone. Ehman reached for his red pen. He circled the sequence. And beside it, he wrote the word that would make history. Wow! The alphanumeric sequence 6EQJ5 doesn't look like much. To the untrained eye, it's just a string of characters on aging paper. But to radio astronomers, it's a fingerprint, a signature written in the language of hydrogen. The WOW signal was detected at a frequency of 142,456 megahertz. That number is significant because it's tantalizingly close to what's known as the hydrogen line, 142,420, 4,058 megahertz, the natural frequency at which neutral hydrogen atoms emit radio waves. Hydrogen is the most abundant element in the universe. Every star, every galaxy, every cloud of interstellar gas is rich with it. That's why scientists have long speculated that any civilization trying to communicate across the cosmos would choose the hydrogen line as a universal meeting point, a cosmic waterhole where intelligent species might gather to exchange messages. The signal was narrowband, less than 10 kilohertz wide. In radio astronomy, narrow signals usually mean artificial transmitters. Natural cosmic sources tend to broadcast across broad frequencies. But this signal was focused precise, like a laser beam cutting through fog. And then there's the duration. 72 seconds, not 60, not 75. Exactly 72. That number isn't random. It's determined by the physics of the Big Air telescope itself. As Earth rotates, the telescope's beam sweeps across the sky like a lighthouse. Any fixed source in space, whether a star, a planet, or a distant transmitter, will appear in the beam for exactly 72 seconds before rotating out of view. The signal's duration matched this window perfectly, rising and falling in the exact pattern expected for a distant cosmic source. The intensity was equally remarkable. 30 standard deviations above background noise, 30 times stronger than the random static of the cosmos. If you were listening to space on a radio, this would be like hearing a whisper suddenly become a shout. The signal came from the constellation Sagittarius, roughly 2.5 degrees south of the Sagittarius star group. In galactic terms, that's close to the plane of the Milky Way, where stars are dense and civilizations might flourish. It was near the globular cluster M55, a ball of ancient stars that has burned for billions of years. But here's the mystery that still haunts astronomers today. The Big Ear had two feed horns, two ears listening simultaneously to slightly different parts of the sky. Only one of them detected the signal. The other heard nothing but silence. This dual horn design means we can never know the signal's exact origin. It came from one of two possible regions, separated by half a degree. It's as if someone whispered in your left ear, but you can't be sure which direction they were standing. When the telescope returned to that same patch of sky minutes later, the signal was gone. It hasn't been heard since, not in 47 years of listening. Not with telescopes 1,000 times more sensitive than the Big Ear. One signal, one moment. One chance, and then nothing. The WOW signal presents a puzzle with no easy answers. In the decades since its discovery, scientists have proposed dozens of explanations. Some are mundane, some are exotic, all are uncertain. The most tantalizing possibility is that the signal came from an extraterrestrial civilization. The evidence is compelling. The frequency near the hydrogen line, the narrow bandwidth suggesting artificial transmission, the intensity far exceeding natural sources. Robert Dixon, former director of the Ohio State University Radio Observatory, believed the signal's characteristics pointed to intelligent origin. The way it followed the telescope's beam pattern indicated it was at least as far away as the moon. The fact that it never repeated suggested a targeted transmission rather than a continuous broadcast. But the extraterrestrial hypothesis faces a devastating problem. If an advanced civilization wanted to communicate, why send only one brief signal? Why not repeat it? Why not include some obvious pattern or message? The silence that followed suggests either a catastrophic event at the source, a transmission beam that swept past Earth only once, or something else entirely. In 2017, a new theory emerged from an unlikely source. Antonio Paris, a professor at St. Petersburg College and former analyst for the U.S. Department of Defense, proposed a natural explanation. Two comets, he suggested, had passed through the region of sky where the signal originated. Comets carry enormous clouds of hydrogen gas. As they warm near the sun, these clouds can emit radio waves at frequencies near the hydrogen line. Paris identified two specific comets, 266P Christensen and P2008 Y2 Gibbs, that were in the correct position in 1977. When he observed comet 266P Christensen during its return in 2017, he detected radio emissions at 1420.25 MHz. The frequency wasn't identical to the WOW signal, but it was close. Close enough to raise eyebrows. The comet hypothesis explains why the signal never repeated. Comets move, they leave the region. They don't come back for decades. By the time anyone looked again, the source was hundreds of millions of miles away. But the comet theory has critics. Jerry Ehman himself remains skeptical. The signal strength from the comet was weaker than the original WOW signal. The comets weren't precisely at the signal's location. And comets had been observed before without producing such intense narrowband emissions. Then, in 2024, another possibility emerged. Researchers Abel Mendez and Kevin Ortiz-Ceballos proposed that the WOW signal was caused by a magnetar flare, a sudden burst of energy from a highly magnetized neutron star interacting with an interstellar hydrogen cloud. Magnetars are among the most extreme objects in the universe. They pack the mass of the Sun into a sphere only 12 miles across, with magnetic fields trillions of times stronger than Earth's. When they flare, they can outshine the rest of the galaxy combined. According to this theory, a magnetar flare stimulated hydrogen atoms in a nearby interstellar cloud, causing them to emit a brief, intense burst of radio waves at the hydrogen line frequency. The mechanism is similar to how a laser works, stimulated emission producing coherent, focused radiation. The magnetar hypothesis explains all the observed characteristics: the narrow bandwidth, the intensity, the duration, the fact that it never repeated. Magnetar flares are rare and brief. We might wait centuries for another one in that same region of sky. This research, submitted to the Astrophysical Journal in August 2024, represents the most promising natural explanation yet proposed. If confirmed, it would be the first recorded instance of an astronomical maser-like flare in the hydrogen line, a new phenomenon that could explain other mysterious radio signals detected by telescopes around the world. Other theories have been proposed and dismissed. Interstellar scintillation, twinkling caused by ionized gas, can produce brief bursts of radio waves, but not with the WOW. Signal's precise characteristics. Space debris reflecting terrestrial signals was considered and ruled out. Terrestrial interference from aircraft or satellites was deemed unlikely given the signal's beam pattern and intensity. Each explanation has strengths. Each has weaknesses. The truth may lie in a combination of factors we haven't yet imagined, or it may remain forever beyond our reach. The Big Ear telescope itself is gone. In 1998, the land was sold to developers. The telescope that heard the universe's most famous whisper was demolished to make way for a golf course expansion and housing development. We cannot go back. We cannot listen again with the same ears. The WOW signal exists now only in yellowed printouts and digital archives, a ghost in the machine, a question without an answer. Despite decades of searching, the WOW signal remains unique. No other signal has matched its combination of intensity, frequency, and characteristics. It stands alone in the annals of astronomy, a single data point that refuses to fit any pattern. In 2022, science communicator Alberto Caballero took a different approach. Using data from the Gaia Space Observatory, he searched for sun-like stars in the region where the WOW signal originated. He found 66 candidates, stars with temperatures, sizes, and brightness similar to our own sun. One star stood out, catalogued as 2-mass 1928-1982-2640123. It lies approximately 1,800 light-years from Earth. It's a G-type star, just like the sun, same temperature, same color, same life-giving warmth. If the WOW signal was a message from another civilization, this star represents its possible origin. Think about that distance, 1,800 light-years. If a civilization there sent the signal in 1977, they sent it when the Roman Empire was crumbling, when the Library of Alexandria still stood, when humanity was just beginning to dream of other worlds. The signal we detect would have left their world before our telescopes existed, before radio astronomy was invented, before anyone on Earth was listening. Today, SETI researchers continue the search, the Allen Telescope Array in California. The Breakthrough Listen Project. China's fast telescope, the largest radio dish in the world. They listen day and night, hoping to hear another whisper from the void. So far, silence. But the search continues. Because the WOW signal taught us something profound: the universe might be talking. We just need to learn how to listen. The WOW signal reminds us that we are small creatures in an infinite cosmos, straining to hear voices that may never come. It teaches us that mystery endures, that even in an age of satellites and supercomputers, the universe can still surprise us. Whether the signal was a message from another civilization, a cosmic accident, or something we haven't yet imagined, it changed how we see ourselves. We are not alone in our curiosity. Somewhere, something stirred the hydrogen atoms of the galaxy in a way that made Jerry Ehman write, "Wow," on a summer night in Ohio. The signal may never repeat, the mystery may never be solved, but the search continues. Because in the end, the most human thing we can do is listen. The WOW signal remains unsolved. End of script, total word count.